Hi, and welcome to Car Corner. My name is Richard Saxon. I'm the coordinator of the automotive programs here at the Community College of Philadelphia. In today's episode, Dan Reed is going to clear the air about oxygen sensor diagnosis. If you have any questions about our programs, please check us out at the website. Okay, now it's time to get it in gear.
Hi, I'm Dan Reed with the Community College of Philadelphia's Automotive Technology program. Welcome to Car Corner. Today, we're going to be taking a look at what's involved with trying to repair a check engine light on a car. Now, check engine light can come in many different shapes and sizes. You can have an engine symbol with a lightning bolt through it. You can have the words check engine. You can have the words service engine soon. However, when that light comes on, you have to be aware that it means that the vehicle has detected a fault with the emissions or the engine electronic system of the vehicle. Now, what people used to think is when that light came on, they would stop the car and get out and pull the dipstick out and check the oil, and the oil would be okay, and they would put the dipstick back in and they would just keep going, and they would assume that that light was on and it meant that, well, I checked the engine, I did my job, it's there in the car, it has oil, it runs, so there must be no problem. However, while that may have been true at one time for cars with check engine lights today, and in fact since 1996, really monitor the vehicle's emission system to make sure that the car is running efficiently and it's not polluting. So when that check engine light comes on, it's a good time to start to think about actually getting the problem fixed. Now, unfortunately, most people, when they see that light come on, they immediately think a high dollar repair is what I'm going to need to fix the car. And the fact is manufacturers have really engineered the cars extremely well. And if you're careful with your diagnostics and you follow a methodical pattern, you don't end up replacing 20 parts in the car. In fact, you should only ever replace one part, which is the part that actually failed. The problem that most people have is when they go through this process to actually figure out the problem with the car, they get sidetracked. They go on the internet, which is fine, but maybe they kind of get sidetracked and they don't do the best diagnostics in the world to actually find the problem, and they spend some real money and they replace a part and it doesn't fix it. So that's an expensive way to make a mistake. We try not to do that too much. The other way that people get sidetracked is maybe they just kind of listen to other people, and again, they don't do the proper diagnostics. Diagnostics in this industry are key. It's what separates backyard mechanics from professional automotive technicians, and it's that diagnostic, logical step that you walk through from start to finish that helps you pinpoint the problem. If you think about how doctors work, when you walk in with a headache, a doctor doesn't immediately jump to the biggest, most expensive conclusion and put you under surgery. They try several different things, and they start not by giving you just medication and sending you away. They start by asking you questions and running diagnostics before they start to do anything. So cars actually follow a very similar diagnostic trouble path to go through. When your check engine light turns on, it's important to remember to, first of all, take a look at how that check engine light is functioning. If the check engine light is flashing on and off once per second as you're driving and the car seems to be losing power, that's a serious problem. That flashing check engine light is designed to get your attention and basically tell you, stop driving the car. If you continue to driving the car while that check engine light is flashing, you're going to cause expensive damage to a device known as a catalytic converter. I've talked about catalytic converters in the past, and today's show isn't about them, but what you have to realize is when that light is flashing, your car is suffering what's known as a major misfire. Major misfire means that the car is not running on all of its cylinders, and when that happens, you run the risk of damaging that catalytic converter. Catalytic converters, if you've ever had to replace them, you know that they're extremely expensive. If you turn your car off and don't drive it while that check engine light's flashing, you prevent that damage. So that flashing check engine light is designed to get you to stop driving the car. You're going to cost yourself more money in the long run if you continue to drive, and you're drastically polluting the atmosphere and you're wasting gas. So check engine light's flashing, stop driving the car, get it looked at immediately. If the check engine light just happens to pop on one day while you're driving, but the car seems to drive normally, light's not flashing, there's no major loss of power, it's not running funny. That's an indication that there is a code, diagnostic trouble code, stored in memory of the car. Now we're going to use one of two diagnostic trouble code scanners to basically talk to the car's computer to try to figure out what the problem is. If that's the case, we're going to go through and we're going to logically go through the process of repairing the vehicle, and then we're going to figure out what the problem is, replace the part, and hopefully fix the problem. So let's get started. So this is our 2009 Ford Fusion, and we have a check engine light issue with it, and I'm going to show you how we're going to get the trouble code to see what the check engine light is all about. So I have this little camera with me called a GoPro, and I'm going to carry it over inside the car, and I can show you exactly what the check engine looks like, and let's go take a look. I'm going inside the car, and when I turn the ignition on, I'm going to see the check engine light right there, and that's the little symbol that looks like an engine. And when I start and run the car, that light should go out. But it doesn't go out. It stays on, which means there's a code in memory. So what we're going to do is we're going to get that code and figure out what the problem is. So now that we verified that our check engine light's on in the car, what I have here is a small handheld diagnostic scanner. Now this type of scanner is typically used just to check engine and transmission codes. Now since we have a check engine light, that's right up the scan tools alley. Some other more advanced scan tools are going to be able to really communicate with the car and really get in and do some intricate diagnosis, maybe with the airbags or the anti-lock brake system. Again, this scan tool is just for the check engine light. So I have this end of the cable already plugged into the car. I have the car turned on. It doesn't have to be running. And as soon as I connect this up, it's going to link to the car, and it's going to, well, just like that, give us our trouble code. Now it looks like here our trouble code has a number. All trouble codes have a number, and starting in 1996 they had a generic numbering system called OBD2. It stood for Onboard Diagnostics Generation 2. The P0053, it says here that it is a heater resistance bank 1 sensor 1, and that's heater resistance is going to be in regards to those words HO2S. It stands for heated oxygen sensors. It'll keep going back and rescanning as I'm just sitting here waiting. It shows me also that it's what's known as a generic code, which is why the generic scan tool can read it. And really, this is the first big clue, because up until then, I had no idea what the cause of the check engine light was in the car, and it took a computer to talk to the computer. So now that we know that the problem is with our oxygen sensor, let's take a look at oxygen sensors and how they work. Our check engine light is in regards to an oxygen sensor. Now, an oxygen sensor, when people hear the word oxygen sensor, they think, well, it must somehow measure the oxygen in the atmosphere, which is partially true. What an oxygen sensor does is an oxygen sensor is mounted in the exhaust stream of the vehicle. Now, most cars have at least one, if it's an older vehicle, and newer cars might actually have 5 in the exhaust stream, depending how complicated the engine is. What the oxygen sensor does is the oxygen sensor is the primary feedback sensor to the fuel system, goes back to the computer that controls our electronic fuel injection, and it helps tailor the fuel economy of the vehicle. So when you have an oxygen sensor failure, it can be, it's something you want to fix. Basically, if you leave it alone, it's going to basically cause the car to waste gas. And going back to that catalytic converter, it could ultimately damage that catalytic converter if you let it go long enough. So what is an oxygen sensor? Well, this right here, this is one of the oldest types of basic oxygen sensors that we have, and it's what's known as a single wire oxygen sensor. Now the way this thing works is this end, the tip, screws into an exhaust manifold through a surface called a bung, and it's going to be mounted down in the exhaust stream of the vehicle. Now, as the exhaust gas passes over that sensor, it's going to do 2 things. Obviously, the air that we're breathing has a certain percentage of oxygen. It's actually, our atmosphere is made up of 21% oxygen. The exhaust gas in the car has a lower content of oxygen. It might only have 1 to 2% of oxygen. So one side of the sensor, the outside here, this part, is exposed to the atmospheric air that we all breathe. The other part here is mounted down inside the exhaust manifold. It's basically living in a poisonous atmosphere. The way the oxygen sensor works is it measures the difference of the oxygen content between the oxygen outside and the oxygen in the exhaust manifold, and it actually generates a small amount of voltage like a battery. The battery voltage is very weak. It generates about 1 volt, and it only generates this 1 volt under extreme conditions. It actually has to see a very low oxygen content on this side and a very high oxygen content on this side, the part exposed to the outside world that we all breathe. The other thing is the sensor itself actually has to reach about 600 degrees before this battery actually starts to work. So oxygen sensors, they have a rough life. They live in a poisonous atmosphere and they get extremely hot. And like I said, they have to get to about 600 degrees before they work. So early oxygen sensors like this guy would have one wire going back, and this wire would ultimately go back to the car's computer, and it would help the computer calculate the air-fuel ratio. If the car was dumping too much fuel into the exhaust, that's going to cause what we call a very rich exhaust, and that's going to cause a very high voltage, 1 full volt. At that point, the computer's going to see that 1 volt signal and go, I see 1 full volt. I'm running too rich. I need to lean back on that mixture, and it's going to actually cut back the fuel through the fuel injectors, which in turn is going to cause the oxygen content to raise in the exhaust stream. We call that a lean condition. The sensor at that point is going to see a very weak voltage, down to 0.1 volts, almost no voltage at all. That cycle of switching between rich and lean happens about once per second as you drive. So the car's constantly switching between this rich and lean. Now the rich and lean is a very narrow band, and it's tailored for excellent fuel economy. And it's one of the biggest reasons why cars went from carburetors to electronic fuel injection was because of this guy. This guy can't control a carburetor very well. Manufacturers had a really hard time tailoring fuel economy with a carburetor. You could set it, but as the carburetor wore out, your fuel economy tended to go in one extreme, lean, in which case the car would stop running, or rich, in which case the car would start polluting, blowing a lot of black smoke and wasting gas. Oxygen sensors really help fix this problem with the advent of fuel injection by preventing that fuel loss, giving us good fuel economy. The oxygen sensor has been around for a long time, and like I said, this older design worked great for a long time, but if you remember back to that 600 degrees, it takes time for the sensor to heat up. So manufacturers realized pretty quickly that they had to do something to help, help heat things up a little bit. So what we came up with is we came up with other oxygen sensors, like this guy right here. Now this guy has 2 wires. You notice it has a blue wire and a white wire. Colors of the wires aren't that important, but what this guy has is it has an internal heater on the inside of it. And this heater helps light up that oxygen sensor very quickly to 600 degrees within roughly about a minute. It's sort of like a miniature toaster oven. And that worked pretty well until manufacturers realized that the power that we were sending through this guy had to be returned through this rusty flange or a rusty fitting back through a rusty exhaust manifold, and the heaters were not working and the sensors were not as accurate as they could be. So what did manufacturers do? They added another wire. What we had later was a 3-wire oxygen sensor. And what this gave us was it gave us a good signal for the heater, the ground for the heater, and we still had our 1 wire back through to the computer. So that worked great, except that signal going back to the computer could even be better. So what did manufacturers do? Yeah, you got it. They added another wire. So what most cars have today is they have what's known as a 4-wire oxygen sensor. 2 of those wires, typically the white wires for most manufacturers, are the heater circuit, and then the black wire is the signal back to the computer, and the gray wire as a ground reference signal for that computer as well. So everything is a nice solid electrical connection now through good connectors. We don't have to rely on rusty connections through the exhaust manifold to send that signal back to the computer. So let's take a look at what's involved in actually removing an oxygen sensor. When it comes time to remove an oxygen sensor, they can be a little tricky to get at because one, they're in the exhaust stream, and they tend to last in most vehicles anywhere between 30 and I've seen them go as far as 150,000 miles easy with some vehicles. So they're in the exhaust gets really brittle, it gets very rusty, it can be a very cramped working environment, and so sometimes getting to the sensor can be a little bit difficult. Now, manufacturers, fortunately for oxygen sensors for the most part, agreed on a standard, which is that the sensor itself takes a 22 millimeter wrench. 22 millimeters is generally the accepted size for most oxygen sensors that are the screw-in type. And if you can get onto the sensor with a wrench at 22 millimeters, that's pretty good. And you're going to need a good-sized wrench to actually work this loose. If you can't get to it with a wrench, it might be tempting to use the box end of the wrench to give you a little more range of motion rather than just the two flats. And we also have more grip surfaces around the base of the oxygen sensor. The problem is I can't fit this over top of the connectors. And if I cut these connectors, there's some disagreement in the industry that you can easily reassemble them and other disagreements that you can't. I'm not a huge fan of cutting and splicing oxygen sensor wires for a couple reasons. One is the wires themselves aren't actually copper. A lot of times they're stainless steel. And if you ever happen to cut open an oxygen sensor harness, you'll see that the wires are they're silver. They're not copper colored, and that is because they're stainless. The other thing is that because they are stainless, you can't easily solder stainless steel with a regular electronic soldering iron. So that connection is never really great when you go ahead and do that. The other thing is there's some disagreement from manufacturers about the actual coating of the stainless steel wire covering. This coating has to, again, to be able to withstand extreme temperature environments. And if we just put on some electrical tape or some butt connectors or something like that, or even heat shrink tubing, that's going to get really hot and it could actually fail and cause a short or your electrical connections to fall apart. Now, a couple companies do make an actual special connector that you can disassemble and reassemble for splicing harnesses together. And some manufacturers, what they'll do is they'll sell you what's known as a universal replacement oxygen sensor. And it's literally just an oxygen sensor with 4 wires. And then the idea is that you cut your old harness and use your factory connector to plug back into the computer. And then you use the aftermarket connector that you bought and you splice the two together with a special electrical connector. They work fairly well. The thing you have to look out for is some manufacturers are actually now using a 5-wire oxygen sensor, in which case that doesn't work. That's called an air-fuel ratio sensor, and it's a little bit of a different type of animal. So the 22 millimeter wrench works good as long as you can get to it. Now the other thing is I like to use a good penetrating spray. If I know that I have to take an oxygen sensor out, I'm going to want to spray the base of the sensor. Don't spray the whole sensor, don't spray the wire harness, and certainly don't get a lot of oil inside the sensor. Just spray it at where it meets the exhaust manifold and let it sit. The longer you let it sit, the better it does its job. And a lot of times after you let it sit for maybe an hour or two, you let the rust penetrant work its way in there, and it really works nicely at breaking that rusty bond. If you still can't get in there, you may have to use a special type of socket called an oxygen sensor socket. Now, these are 2 different styles, and this socket is designed to go on the end of a 1/2-inch wrench, and you'll see that it has this big slot cut in the middle of it. Now, the slot is designed so you can pass that over the sensor like this and get it down on top there, and you have the slot sticking out so that way the wires don't get twisted as you turn it off. Otherwise, you could just use a regular 22 millimeter socket. The problem is the wire harness gets in the way. This works really well, but it's kind of tall. It might be a little hard, a little bit of for some confined space work. So what manufacturers came up with was this special crow's foot adapter. And this guy just slips right over the wire harness and goes right down on top. And then I can take my regular old ratchet, put this on top here, and there we go. And just break this guy loose. Now this is obviously been pre-loosened. When you go to remove the oxygen sensor, it's a good idea to make sure that you can get to the electrical connector and disconnect that first. Because what will happen is as you twist the sensor, if you don't unhook and unbolt the electrical connector, it's going to actually start to twist the wires, and we don't want to cause a bigger problem than we're going to need. If we have to reuse this sensor, we have to be really, really gentle with these things. So you're going to just want to unscrew the unit as a whole and kind of work the wires around. Now when it comes time to put a new sensor back in, one of the tricks that manufacturers have learned is that by adding a little bit of anti-seize compound on the threads of the oxygen sensor are really helpful in making sure that that rust bond doesn't form again if we have to remove the sensor in the near future. Now obviously if we put the sensor in and we leave it for 100,000 miles, I'm not so sure how good the anti-seize compound is going to work, but one of the things that I see people make a mistake with is they think if some is good, then more is better. And the fact is when you go to put on the anti-seize compound, you really only need a very, very small amount of this. And this is obviously a whole lot. Let me just wipe some of this excess off. And I'm just going to put a dab, really, really small amount of anti-seize compound right there and only on the threads. You never want to get it actually on the sensor area itself. If you do that, you run the risk of contaminating the oxygen sensor. So when it comes time to put it back in, we simply take our sensor, thread it back in through the exhaust bung, snug it down, and then use my tool and torque it down. Okay. Make sure it's snug. When I start the vehicle, I want to make sure that there's no exhaust leaks. And at that point, if that fixes our problem, well, then we're good to go. So that's what's involved in changing an oxygen sensor, and I'm going to show you how to do it on the car behind me. But our oxygen sensor in question has a defective heater circuit according to the trouble code that we got. So how do we check that? Well, according to the manufacturer, what they're going to have us do is they're going to have us measure the resistance of the two wires and see if there's specific resistance. If there's no good resistance there, then we know that our heater inside our oxygen sensor is defective. Now the big mistake that a lot of people make is they read the scan tool and the scan tool says something about oxygen sensor. And they run out to the auto parts store and spend $50 or $150 or $250 on a sensor, put it in the car, do everything right, and the problem's still there. Again, you have to go through the diagnostics to make sure that you are actually replacing the part. There could be a problem somewhere else in the circuit. So we're going to make sure that we do our thorough diagnostics. The other thing is I can show you a simple way to test an oxygen sensor. And what we're going to do is we are going to take an older two-wire sensor. Where did I put it? There it is. We're going to take this older two-wire sensor right here. And what I'm going to do is I'm going to use a digital voltometer, which is a electrical test tool. And I'm going to set this up. And what we're going to do is I'm going to show you how the sensor works with the voltage that it's going to generate. So let me plug this guy in and hook this up. And you're going to see that as soon as I hook this sensor up, it's going to make almost no voltage whatsoever. Set the range here. And it's now set to show me millivolts. And it's effectively zero. We're looking at a scale that's really showing us, if we can imagine this is $1, we have a 0, decimal point, and then we have cents, and then we have basically hundredths of cents all the way at the end. So the way that we're going to test this is we're going to heat the sensor. Now this is more of a demonstration. It's not a great way to test an oxygen sensor in a car, but I like to just demo it. This is a demo that I use for the students here. So I'm going to move the meter over a little bit so I don't get it too hot. But what I'm going to do is I'm going to take a propane torch and I'm going to heat the sensor. And you're going to see that the voltage is going to start to rise on the sensor as it heats up. Now, if you remember, the sensor has to get to 600 degrees, and that's a pretty big chunk of metal, and this is just a propane torch. And that means that it's going to take a couple seconds, if not at least a minute, for this to start to heat up. So I got my oxygen sensor cooking pretty good, and my voltage is still 0. And we should start to see some voltage come up there. A little bit of voltage coming up as the sensor starts to heat up. And the sensor should almost get to a full volt if everything's working. And right now we're at 40, 50, 60, 70, 80, 90, almost a full volt. Not quite a full volt, but pretty close. And as soon as I pull the flame away, it should immediately drop. So I should go hot, should heat right back up to where it was. If I pull it away, it should drop quickly. And this sensor is actually doing a pretty good job of switching between, this would be a rich signal right here, and that would be a very lean signal right there. So if you were monitoring this in a car, as you drove, you would see it constantly switch between that higher voltage, which is almost a volt, and then that leaner voltage, which is almost no voltage at all. So as you're driving again, that oxygen sensor is switching between rich and lean, rich and lean. It does it about once per second, and it's going to take a little while for that sensor to cool down before I can handle it. While that's cooling down, I want to talk about a couple other things which could cause a check engine light to turn on. However, they're not oxygen sensor related, but sometimes there's an old saying, you shouldn't kill the messenger. The oxygen sensor is just a messenger. It is telling us the overall air-fuel ratio of the vehicle. And one of the things that can happen is that occasionally some of our rubber vacuum lines under the hood, as a car ages, this rubber is going to start to get brittle and it's going to become porous. As that happens, it's going to be able to draw outside air in through the air inlet system that's not counted by certain sensors. So it's kind of like kids sneaking in the back door to a movie theater. When that happens, the oxygen sensor is going to see it, and it's going to report that it sees a problem, and it's going to set a trouble code. And the fact is people will go and they will just replace the oxygen sensor because that's what the trouble code was. But the problem is that the vacuum line is actually ripped or torn. So a good visual inspection anytime that we have an oxygen sensor fault is to make sure that these rubber vacuum lines underneath the hood are in good shape. If they're defective, and I'm not talking about fuel or air conditioning lines, just rubber emission lines, you should definitely replace them. They're not expensive, and a lot of times they're the fault of check engine lights. The other thing that can happen is our good old friend, the gas cap. The gas cap from this company actually says, make sure you tighten your gas cap or the check engine light's going to turn on. Now, this is going to cause a different type of trouble code, a code for the evaporative emission systems if it's faulty. But the fact is people, a lot of times, they forget just to tighten down the gas cap, or in some cases, they may actually leave it off the car back at the gas pump and not realize it until the check engine light comes on. And again, this happens because manufacturers and the government are trying to control the amount of pollution in the atmosphere. If this cap is not sealed, you're venting gasoline fumes, hydrocarbons to the atmosphere, which causes smog. So manufacturers and the government want to make sure that that cap is closed and that cap is tight, and if it's not, your car is going to pull up a check engine light. Now, fortunately for us in the industry, the gas cap is actually one of the first things we go for because it's the most commonly it's the only part of the emission systems the customer actually touches. Yeah, that's part of the emission system. So we want to make sure that if there is a check engine light and there is an evaporative emissions code, first thing we do, walk over to the gas cap, give it a tug, make sure that it's tight. If it's not tight, you can be pretty assured that the gas cap was the problem. But since our problem is the oxygen sensor, let's go take a look and see what's involved in taking it out of the car. So what I've got here is I have a more advanced scan tool, and I have this out here because I also wanted to show you I have a nice big thick stack of information that I've printed out as well. Again, I'm not just going to go in here and just replace the oxygen sensor because the code was for oxygen sensor. The fact is the manufacturer has given me a nice drawing here on this figure 58 of the actual connector pins, and I'm going to need them when I do some diagnostic testing here. And then I also have a listing of possible faults which could cause this sensor fault. And it basically goes through and it says that the problem is most likely with the heater circuit, but that heater circuit could actually is powered by the processor. So it's going to, if it need be, it's going to have me go through and check the wires back to the actual computer in the car that control that oxygen sensor. Now I mentioned that cars tend to have several oxygen sensors, and right here on this drawing figure 56, I have a 4-cylinder engine, and it's laid out a little differently than the one that we have in the car, but what sensors are known as is bank 1, sensor 1, and bank 2, sensor 2, or bank 1, sensor 2. And what the banks are is they're the sides of the engine. So you have the left side of the engine and the right side of the engine. And bank 1 is always going to be the bank where cylinder number 1 is located. So it's not the same for every car. You really need a diagram like this to actually check it. And our sensor that we're showing a fault with according to the code is this one. It's heated oxygen sensor, sensor 11. It's not 11, it's bank 1, sensor 1. And that means that it's the sensor that is in the exhaust manifold before our catalytic converter. So this car has 2 oxygen sensors. If I just go out and I say, hey, I need an oxygen sensor, I don't know which one I need. I get underneath the car and there's 2 of them. I have to take a guess. I might guess wrong. So at least this way I know I'm going to be looking at the right sensor. So now that I know what sensor is definitely a fault, I've located inside the car, I'm going to fire up my scan tool and we're going to actually check it electronically, which I can't do with that other scan tool, but we're going to take a good look at that heater circuit with this scan tool and see what we got. So I'm going to start the car up and we'll get started. So I'm going to go in and I have to tell the computer what type of car it is that it's working on. And it takes a little second there to communicate. And I have to tell it that it is a Ford and that our car is a 2009. It is a domestic Ford. And our vehicle is a Ford Focus SE. And there's our engine. It's a 2-liter Duratec US domestic. And I'm going to come in here and say OK. And at this point, you can see I have access to a lot more control than I do with that generic scan tool. I'm going to come over here to, let's take a look at engine. And I'm going to come over here to data display. And I'm going to come over here to O2 sensor data. And I'll say continue. And I should be able to see the information for this oxygen sensor. It's telling me here that the heater is commanded on. So the processor is telling that heater that it should be on. It's telling me here that the heater control is also on in the processor, that the heater control status is okay, but it tells me down here that oxygen sensor 1 is warm and ready to operate, and it says no, and then right here, this guy just switched over here to a fault. So that verifies that our oxygen sensor is most likely at fault and that our processor is okay. Now, I can't see that information at all with the generic scan tool. I really need something high-end like this in order to actually even see this data. So now that I can verify that that is faulty, what I'm going to do is I'm going to go ahead and pull that oxygen sensor out, and we're going to measure it. So now that we know that our oxygen sensor is suspect, what we're going to do is we're going to go in and remove the oxygen sensor. And what I have is I have that little GoPro camera located on the back of the engine bay. So you're going to see exactly what my hands are doing while I'm in the engine bay. So let's get started. I'm going to start by reaching in and disconnecting the connector from its base. And sometimes it's helpful just to give that a tug. I'm going to unplug my connector and pop it out of its harness. And it's a little warm down here, as we did have the engine running. And let's see here, that connector is going to come off. Like that. So now my sensor is disconnected, and now I'm going to use my oxygen sensor wrench to go in and loosen it up.
Can you say that again? Can you just tell me from what you were doing?
Okay, coming up. And now what I'm going to do is I'm going to use my oxygen sensor wrench to go in and extract that sensor. And then we're going to test it again just to make sure. And that came loose, really nice and easy. And I'm going to reach in and carefully unscrew my very warm sensor. So the sensor's out, and what we're going to do is we're going to check it. Now, again, going back to the manufacturer's paperwork, what I have here is a drawing of the sensor, and the diagnostic step that we're on says to check and make sure that the oxygen sensor heater circuit is good, and it should be, the resistance should be less than 5 ohms. Okay, should be around 5 ohms. So let's take a look here. Now I have this paperwork again, and they're going to show me here that what I'm looking for is I'm looking for the heater signal, which is pin 2, which is that guy right there, and then also vehicle power, which is pin 1, which is going to complete my heater circuit. So if I go between pin 1 and pin 4 on my connector, if I hold the connector the same way, that's going to allow me to do a resistance measurement with my ohm meter, and let's see what I get. Take my meter, and I'm going to connect one lead to pin 1. Just double check my work. And I'm going to connect one lead over here. And first check my meter. Should be good. And then I'm going to connect this lead to pin 2. And that shows OL. And it shows me that it's open. So that means that the heater circuit in this oxygen sensor is bad. And what we need is a new oxygen sensor. So let me go and grab an oxygen sensor, and then I'll come right back and we'll actually check the new one before we put it in the car, and then we'll put it in the car and we'll see how we make out. So here's our new sensor and oxygen sensor. We had our parts guy go out and get us one. So we're going to take this guy out of the box, and the first thing I'm going to do with it is I'm going to notice a couple things. It looks like there's already some anti-seize compound on it, and a lot of manufacturers do that. They give you the anti-seize compound as a courtesy. The other thing I want to check here is I want to make sure that the connector ends are exactly the same, and that's because I'm going to have to make sure that my old sensor harness in the car plugs into my new oxygen sensor, and they certainly look the same. And now what I'm going to do is I'm going to check the sensor before I put it in the car, so I can make sure that I'm not going to put in a failed part. And if I come over here and I check again between pins 1 and 2 with my meter, I should get a reading of under 5 ohms, and yep, I'm at 3.7 ohms. So this sensor has a good heater circuit in it. And now that I know that, we can pop this back in the car. Always hand thread the sensor in first. Don't ever put the tool on right away. I'm going to make sure that you don't cross thread it in this exhaust manifold. If you do, it's going to be a really, really expensive repair to get this rethreaded. I'm going to tuck the harness out of the way for now, and I'm just going to snug this down with my wrench. And I don't want to over tighten it, but I want to make sure that it's snug. And then I'm going to carefully route the oxygen sensor wires around and put them back in their original harness. What you don't want to have happen is you don't want to have the sensor wire rub up or melt against the exhaust manifold. Even though there's a heat shield here and there's a heat shield on this wire, you really want to make sure that these wires aren't compromised in any way as the car goes on down the road. Straighten those out. And I'm going to plug my connector end back in, making sure that the harness again doesn't rub up against anything. And then I can plug my connector back in. And make sure that it is back on its mount where it belongs, like that. And we'll put this guy back here too. And they're both out of the way. They're not rubbing up against anything. Wire isn't pulled excessively. So I think now at this point, what we're ready to do is erase our trouble code and run the car and make sure that our fault is gone and our check engine light is off. So I'm going to go back in to my scanner, and what I'm going to do is I'm going to go in and I'm going to go in through a different side, and I'm going to go in through the scanner side of the scan tool, and we'll have to go through the whole process of telling it it's a Ford. And what I'm going to do here is, now that I've fixed the problem, I'm going to erase the code. The mistake a lot of people think, and what they do, is they think if they erase the code, it turns off the check engine light and that fixes the problem. Well, as we saw, if there's a real problem with the car, the check engine light is just going to come back on when the car detects the problem again. So you really have to go in and fix the problem. Erasing the light, turning the light off doesn't fix anything. It's sort of like knocking somebody out. It just temporarily gives them amnesia, and then they remember that they had problems. So we go over here, Focus SE, and what we're going to do, I have the ignition key turned on. Car's not running. We're going to come over here to Engine, and we are going to go to Codes menu, and we are going to clear our codes. So we're going to clear our codes. Gives me a warning saying that we're going to erase everything. We're going to basically erase all of the trouble codes stored in the car's memory. So I'm going to say, yeah, that's fine. We want to do that. And then it says clear codes, key must be on with engine. Yeah, well, that's okay, we're good. And it says wait, code's cleared, and we're going to exit. Now, I'm not done, because a good technician is going to go back and start the car and go back and check that information that we looked at before to make sure that our check engine light is still off. So I'm going to go over and start the car, and then we're going to come back and look at that heater circuit to make sure that it doesn't show a fault. So I'm going to go back, and I'm going to come into engine, and I'm going to go to data display, O2 sensor data, and I'm looking over here. So now we can see that our oxygen sensor heater circuit, our controls are on and okay, and looks like we're sending some current here to the oxygen sensor heater, which is good. Before we couldn't do that. And it says that our oxygen sensor status is okay. Before it said fault. So what I'm going to do now is I'm actually going to exit out of here, and let's see if we can back up, and I'm going to go back to the codes menu. And what we're going to do is we're going to see if there's any codes stored in memory. And this code P1000 means that the system hasn't run through all its readiness tests. However, when I get a P1000, it does tell me that the check engine light is turned off. So that's important good news. Let me go turn the car off. Are we going to go look at the check engine light? I forget.
That's okay. You said it was off.
Okay. All right. So our check engine light's off. We found the problem and fixed it right the first time. We used some tools and technology to get that done. We didn't guess. Okay. We used the manufacturer's data, went in and tested everything the way we're supposed to, and we fixed it. We fixed it right the first time. And hopefully you'll have good luck too. I'm Dan Reed. Thanks for watching Car Corner. Drive safely.
There you go. The manly man.
He's not wrong. There you go.
Ready?
Now he's telling me what to do.
Hey, I don't want you to miss a shot.
You know what? Let's do that again.
I
But it's not really.
should be the director.
You should.
It's getting late. Everyone's getting sloppy.
Always checking my red light. What the hell's the matter?